Voyager, the most ambitious space mission in history.
The two Voyager spacecraft are iconic.
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 They're the first probes to truly explore half the planets in our solar system.
Jupiter, Saturn, Uranus, and Neptune.
These went from dots of light in the sky to real worlds.
The Voyager missions have ventured far beyond where other probes have explored.
They are the most distant emissary representatives of the human species.
They're the first spacecraft to taste interstellar space.
Exploring further than any human-made spacecraft has gone before. These are the logs of the starships Voyager 1 and 2. They have crossed the final frontier and are now in interstellar space.
Almost a decade ago, Voyager 1 achieved something that had never been achieved before. It left our solar system.
When Voyager crossed into interstellar space, humans became an interstellar species.
14 billion miles from Earth, their radio signals, traveling at the speed of light, still take 21 hours to reach us.
The Voyagers are so far out that when they look back toward the sun, it's just a pinprick of light, and they would need an exceptionally powerful telescope just to see the Earth.
Their original 4-year mission has been extended to 44 and counting. From their current distant vantage point, they look back on the strange new worlds and bold new science they discovered.
5, 4,
August 20th, 1977.
2, 1. We have ignition and we have liftoff.
The mission begins when Voyager 2 blasts off, followed 2 weeks later by its twin, Voyager 1, which will take a shorter and faster route. Their destination, Jupiter, and then Saturn.
When the time comes that mission is actually ready to go to the launch pad, it's a funny mixture of joy and bittersweet loss.
They become like your children. And that launch is like the birth of a baby. I was standing there watching it climb up into the sky, and we were cheering, we were so happy. Voyager was on its way.
September 1977. Before heading out to the planets, Voyager 1 captures an image to see if everything is working.
As Voyager was flying away from the Earth, we turned the cameras back to take a picture of the Earth and the Moon.
That was the first time you could actually see our home and the Moon together in the same frame.
It was fantastic. What a great first picture for Voyager.
But Voyager 1 doesn't stick around. It's on a tight schedule. Though funded to just explore the two gas giants, mission planners have a much bigger journey in mind: to send the Voyager spacecraft on a grand tour of the solar system to the outermost planets, Uranus and Neptune, worlds that have never been explored. To visit each planet, the probes must stick to a strict schedule, with only a quick flyby of each world. Once reaching Jupiter, they must use every second to complete close-up studies of the planet and its largest moons.
One of the biggest challenges with flyby spacecraft is it may have taken years to get there, but the actual time that you're close to the planet is remarkably short.
The Jupiter close-up data occurred during just 3 days.
February 1979, Voyager 1 begins beaming pictures back to Earth. It's an anxious wait.
This is pre-internet, and so when you look at the data coming in, it's coming in line by line, pixel by pixel.
It was such an exciting time, it was hard to know when to sleep. I brought my sleeping bag into my office so I wouldn't miss a single exciting picture.
both Voyagers reveal an unbelievably dynamic world.
Scientists were able to take a sequence of images of Jupiter that they could put together like a flip book to get a sense of motion, and it was just astounding. Now we can see things moving within the atmosphere of Jupiter in a way that we had no sense of before.
Together, the spacecraft take over 33,000 images of the gas giant. These pictures reshape our understanding of Jupiter, especially its largest moons: Ganymede, Callisto, Europa, and Io.
We saw all sorts of different kinds of landscapes on them, and each one had its own individual type of personality. Of all the moons around Jupiter, and there are a lot, Io was the one that shocked everybody.
We got back this very unusual picture. We saw this bright feature on the dark limb of Io, and we wondered, what could it be?
At first they thought that arc might be another moon behind Io, but the geometry was wrong. There were no moons there. Well, they figured out that these were volcanic plumes.
And that bright feature on the dark limb was a volcano erupting on Io.
Voyager 1 records ash and lava blasting 190 miles into space, 8 times higher than the largest eruptions on Earth.
This is the first time we'd ever seen another volcanically active world anywhere in the solar system, right? It really transformed our ideas, our concept of what a moon could be.
But astronomers were also baffled.
When scientists first saw these images of Io, they had to ask the question, how is this little moon still so hot?
On Earth, we know it's a big planet, it's volcanically active because of plate tectonics, and there's this, ancient heat system inside the planet. When you look at a little moon like Io, you expect, it's going to be dead, right?
But instead, it's the most volcanically active body in the solar system.
Io's volcanism is powered by tidal heating.
As it orbits Jupiter, it gets stretched and compressed by the gravity of Jupiter and the other moons as they all pass by it.
The compression and expansion generates heat, melting Io's interior, a planetary process never before witnessed. And tidal heating may explain another Jovian moon, Europa.
As Voyager flew by and took pictures of Europa, it could see these striations on the surface, and it saw that the crust was really ice.
We started to realize, looking at additional data, that it might host an ocean somewhere in the subsurface.
The possible discovery of an ocean elsewhere in the solar system is groundbreaking. Liquid water is the vital ingredient for all life as we know it.
So we have this liquid water, and it's interacting with a rocky core, making minerals, putting things into the water, all the raw ingredients for life.
It's hard to tell whether or not life actually exists on Europa, but where we find water, it's a good place to search for life.
At Jupiter, the Voyagers discover 3 new moons and a ring system invisible from Earth. Not to be outdone, the planet itself has a few surprises. The probes turn to the gas giant's most famous feature, the Great Red Spot.
Jupiter's red spot is a feature that has existed in its atmosphere since we began looking at Jupiter. It's incredible. What it turns out to be is a storm that has lasted centuries.
The Voyagers reveal a maelstrom of gas, swirling counterclockwise between 2 bands of high-speed winds.
The red spot has been kept in a single place because it's sort of sandwiched between these 2 bands of atmosphere.
Like a whirlpool, an eddy, and 2 currents that are moving next to each other. That may have helped promote its stability over all these centuries.
But Voyager's close-up shots show a far more complex structure than we expected.
It turns out the Great Red Spot is not a single vortex. It's more complicated than that, which you might expect from a storm bigger than the Earth. Voyager actually took close-up images of it and saw several smaller vortices spinning around inside of it.
These small vortices are 10 times larger than any hurricane on Earth. But the Voyagers can't detect how they interact with the spot. It'll take a new generation of space probes to solve that mystery.
So after Voyager flew past, there were lots of questions that went unanswered, and Jupiter is a long way from the Earth, and really the only way to answer some of them was to go back.
37 years after the Voyager flybys, the Juno probe arrives at Jupiter.
The Juno spacecraft has a microwave radiometer. That instrument is able to detect the microwave radiation coming from very deep inside Jupiter, and from that we're able to determine things like its deep composition and its deep temperature.
Juno finds the Great Red Spot stretches at least 200 miles below the surface. And in 2021, a team combines Juno data with Hubble and ground-based telescopes to finally discover what powers the gargantuan storm.
These small storms that are coming in are rotating very quickly. All of that feeds the Great Red Spot and keeps it spinning, gives it that spinning energy that it needs to survive.
The Voyager probes are ready for their next destination, Saturn. But to get there, they must first fly dangerously close to Jupiter. The next stop on the Voyager probe's grand tour of the solar system is Saturn. But the ringed planet is over 450 million miles away from Jupiter. To get there, the Voyagers will need to perform a maneuver known as a gravitational slingshot, which will catapult them from one planet to the next.
We allowed the large gravity of Jupiter to actually capture the spacecraft and start accelerating it toward that massive planet. But we did it at just the right angle, so we would move around it and then continue away from the planet. Jupiter itself is barreling around the sun at very fast velocities. As you pull away from Jupiter, you keep some of that velocity with you.
If it's successful, the slingshot will knock years off the Voyager's journey. If things go wrong, it's game over.
To do a gravitational slingshot, you need to do 3 things. You need to have really good calculations, excellent planning, and perfect timing.
Mission controllers achieve all 3, and the maneuver works. Voyagers 1 and 2 speed up by 22,500 miles an hour and race towards Saturn. 1980, right on schedule, Voyager 1 arrives at the ringed planet. Its sensors probe Saturn's atmosphere and discover it's mainly hydrogen and helium.
Saturn has nearly 100 times the mass of the Earth, but it has so much more volume that when you look at its density, it's actually less dense than water. There's a very old joke in astronomy that if you put Saturn in a bathtub, it would float, but it would leave a ring.
The most striking discovery emerges from the data 9 years after Voyager's flybys, a bizarre cloud formation at the North Pole.
A giant hexagon over the North Pole with sides 9,000 miles long and it's 18,000 miles across. Yeah, that's bizarre.
You don't often think about very stable geometric shapes like a hexagon. That feels like it shouldn't happen, right? You don't get hexagon-shaped clouds on the Earth.
What could possibly create a hexagon more than twice the size of Earth?
Voyager discovered the hexagon, but we didn't have enough information to truly understand it.
Jump forward 24 years after Voyager, and another probe arrives at Saturn, Cassini.
The main difference between the Cassini mission and the Voyager missions, besides Cassini having more cutting-edge equipment on it, is that it was an orbiter. It orbited Saturn for 13 years. The Voyager missions just flew past it.
Cassini watches the pole for several years, capturing thousands of images of the hexagon.
The beauty of the Cassini mission is that it showed us what the hexagon looked like years later after Voyager. It didn't necessarily solve the problem of why this thing exists, but it gave scientists a lot of ammunition to figure it out.
Finally, in 2020, a team solves the mystery. Many cyclones surround a large jet stream at the planet's north pole. Where the two weather systems meet, a hexagon cloud forms. Something we don't see here on Earth.
The trouble with Earth is it has a lot going on. We have oceans, we have mountains, all of that disrupts the atmosphere. On Saturn, there isn't any of that. So you're able to have these very stable airflows that just wouldn't be possible on the Earth. Nature's pretty wonderful.
Next, the Voyagers turned their gaze to Saturn's rings. Their images are game changers.
One of my colleagues in my undergraduate planetary astronomy class was a computer whiz, and he managed to hack into the NASA feed that was going out. We all piled into his dorm room, the professors, the students, seeing images coming from the Saturn flyby.
We thought that Saturn had just a handful of wide, flat rings. Voyager's images reveal thousands of separate rings orbiting the planet. But there's an even bigger surprise, an impossible ring.
When the F ring of Saturn, a close-up image appeared on the screen, and instead of being sort of a single ring, it looked like multiple rings that were braided together. And my professor, Erwin Shapiro, famous planetary astronomer professor, said, "That's not possible."
Scientists pore over the images to figure out what's causing the bizarre structure.
Our basic understanding of rings back then was that they were collections of little particles that were all just following the same orbit.
You'd expect that system to have settled out into, all the traffic on the highway driving in the same direction, parallel lanes, all nice and neat. And you don't expect these weird dynamic interactions that are going on.
Then, scientists find two clues to explain the interactions.
And one of the things that was discovered was two satellites that orbit inside and outside of the F ring, Prometheus and Pandora. It pointed to the idea that the moons and the rings were constantly interacting, but it didn't really tell us how.
Voyager's discovery of the moons doesn't solve the mystery of the braided F ring, but it does tell the Cassini probe, 25 years later, where to look. Cassini watches the tiny moons, looping and twisting around each other as they orbit the planet.
When you have two little moons sort of co-orbiting with the ring, there's a complex gravitational dance that happens with the inner moon wanting to speed up particles, the outer moon wanting to slow them down, and that interesting gravitational dance is what actually helps confine the ring into the narrow structure that we actually see.
By seeing these moons either side, there was an idea that they could be shepherding, they could be holding the ring in place.
Saturn's many moons and complicated rings are like a mini solar system. Now, the two Voyager spacecraft separate to carry out two individual missions. Voyager 1 heads off to explore the edge of the solar system, and Voyager 2 flies into the freezing cold of Saturn's shadow. For over 2 hours, the giant planet blocks all contact with the space probe. After a tense wait, Voyager 2 emerges. But something's wrong with the spacecraft.
Picture after picture of dark sky came back, and we realized something had either happened to the cameras or something had happened to the scan platform.
The scan platform, the vital rotating joint that points the probe's instruments, isn't working. But how can scientists fix a probe 2 billion miles from Earth?
The scan platform is kind of like your head and neck. Imagine the cameras as your eyes. And if you want to turn to look at something, you turn your head, and your neck has to move.
When Voyager 2 passed behind Saturn, it plowed through the rings at 29,000 miles an hour. Maybe a chunk of ice damaged the platform, or maybe the maneuver gave the probe whiplash.
We had been so ambitious in looking at the moons and the rings and Saturn that we had literally squeezed the lubricant out of the bearings of the scan platform, and it got stuck.
The broken scan platform could be fatal for the rest of the mission.
And so we worried, could we fix it? We had Uranus and Neptune ahead of us with Voyager 2. We wanted to be able to fix the scan platform.
To fix it, the engineers employ some space physiotherapy.
We slowly commanded it from Earth and got it to move a little bit at a time until finally we could get those beautiful outbound pictures of Saturn that you see.
With Voyager operational again, NASA agreed to fund the next stage of the mission.
I'm eternally grateful that NASA did decide to complete the grand tour.
There was tremendous relief to know we had a healthy spacecraft, Voyager 2, to go on to Uranus and Neptune.
1986. Boosted by a slingshot from Saturn, Voyager 2 arrives at Uranus. After 9 years in space, the probe is now in uncharted territory.
Ahead of Voyager's encounter, Uranus was really difficult to know much about. We knew what its color was, but it didn't have any obvious features from the Earth. It looked sort of like a generic green blob.
We did know a couple things. Uranus has rings and sits on its side.
Unlike most of the other planets, whose spin axes are oriented more or less perpendicular to their orbital plane, Uranus is tipped over on its side. It rolls around the sun like a barrel at times. There are other times where the sun is shining right down the equator. It's very unusual.
In a flyby lasting just 5.5 hours, Voyager 2 discovers 11 new moons and 2 more ghostly rings circling Uranus. But Voyager 2's strangest discovery is the planet's freakish magnetic field.
Voyager carried a magnetic boom that told us about the magnetic field of the planet, and that turned out to be really interesting.
The strength and direction of Uranus's magnetic field turns out to be unlike any other planet's.
The Earth has a magnetic field, and it's pretty complicated how it behaves, but you can think of it as if there's a giant bar magnet inside the planet. There's a north magnetic pole and a south magnetic pole, and magnetic field lines around them.
On Earth, that bar magnet lines up close to our planet's spin axis. The Voyager probes found the same at Saturn and Jupiter. But Uranus's magnetosphere is different.
The north and south axis of the magnetic field is tilted by almost 60 degrees relative to the spin axis of Uranus. That's strange.
If you imagine transforming the Earth's magnetic field to be like the Uranus one, you'd have the magnetic North Pole down near Miami someplace. It's way out there in left field.
And the magnetic field isn't just tilted.
It's off center. The center of the magnetic field you'd think would be at the center of the planet. It's actually offset by 5,000 miles, which is a lot. We think it may be generated in the mantle of Uranus, where there is molten water, not molten iron.
Extreme heat and pressure breaks water molecules apart and rearranges them into a molten crystal structure, an exotic state called superionic ice.
When we talk about ice, like superionic ice inside a giant planet, we're not talking about ice cubes.
Water has lots of different ways of being, and some of them are really strange.
The half-liquid, half-solid ice swirls around in the outer layer of the planet, moving like liquid metal. Because the ice conducts electricity, this produces the offset magnetic field around Uranus. Voyager 2 also uncovered a gigantic magnetic glitch, but it remained hidden in the data until scientists discovered it in 2020.
What they found was a blip, a strengthening of the magnetic field. and it was about 1 million miles behind Uranus, and whatever was causing this was quite large.
It's a giant magnetic bubble, 250,000 miles across, floating in space.
This type of magnetic bubble is called a plasmoid, and it happens when the magnetic field lines get pinched off, and it can create sort of a self-contained shell.
This means that the magnetic field around Uranus is dynamic and can fracture and interact with the solar wind in very interesting ways.
This can also have some of the atmosphere of Uranus in it, so it's literally leaking gas into space. Uranus is belching.
It'll take another mission to Uranus to truly understand this strange world. For now, Voyager 2 is the only spacecraft to ever visit. And what awaits the probe next could be Voyager's greatest discovery yet. 1989, Voyager 2 makes one last flyby. Neptune is the final stop on the planet-hopping tour of the outer solar system. It's a once-in-a-lifetime opportunity to study the blue ice giant up close.
We had these hints from our ground-based telescope that there was activity in the atmosphere. But what its nature was, what was it like? There absolutely was nothing we had to prepare us for what we were going to see.
Voyager 2 spots 4 new rings and 6 more moons. It detects hydrogen, helium, and methane in Neptune's atmosphere. And it records the fastest winds in the solar system, pushing white clouds across the planet at up to 1,500 miles an hour. And at their center, a colossal dark storm.
There was a dark spot, a big, dark spot on the disk of Neptune. We hadn't seen anything like that from the ground. It was like, what is that? We called it the Great Dark Spot because that's all we could think of at the time.
5 years later, when astronomers look for the Great Dark Spot with the Hubble Space Telescope, they get a surprise.
I was going to look at how it had changed with time and, where was it located, things like that. And I remember I got my first images back from Hubble. No Great Dark Spot. It was gone. It simply wasn't there. Like, what happened? How is this even possible? The Great Red Spot on Jupiter has lasted for hundreds of years. This is only 5 years, and this huge feature was simply gone.
Since Voyager 2, we have seen 7 different dark spots on Neptune's surface, none lasting more than a few years.
As to why that is and what's driving that, those are still mysteries that we haven't fully solved.
Before leaving the Neptune system, Voyager 2 turns its gaze to Neptune's largest moon, Triton.
It was sort of a bit like Voyager's last hurrah. It was sort of one of the last things it showed us, and it was just phenomenal.
Voyager 2's instruments reveal a frozen world. At 391 degrees below zero, Triton is one of the coldest objects in the solar system.
Here was a very intriguing world. We saw these dark streaks on the surface and realized that they were actually sticking up above the surface.
What they were seeing was an active cryovolcano jetting, a jet of black material, something like 8 miles up above the surface of Triton. And then the atmosphere of Triton was shearing it out into a large cloud pattern.
That was one of our first indications of geyser-like activity on a planet other than the Earth. It was almost pandemonium, really, trying to figure out how do you generate this kind of activity on a moon that should be cryogenically frozen solid? Where's the energy source for this?
In 2019, scientists finally identify frozen nitrogen and carbon monoxide in the streaks.
We think now what actually is going on there is it's the action of sunlight shining into some of the darker deposits on the surface of the moon. Just a little bit of a temperature change can take the nitrogen and liberate it off the surface.
In their grand tour of the solar system, the Voyager probes produce an astounding number of discoveries.
Volcanoes on Io and geysers on Triton and little weavy features in the rings of Saturn. It all turned out to be far, far more interesting and alive and dynamic than we ever imagined.
While Voyager 2 leaves the planets behind, its twin, Voyager 1, heads to the edge of the solar system, but not before taking one last snapshot of home, a family portrait.
This idea by Carl Sagan to take this family portrait is just magnificent, and the scientific need for it may have been limited, but the appeal to our sense of beauty, staggering.
This shot isn't in pursuit of a new discovery. It's about finding a new perspective.
This family portrait is a series of 60 images put together into a mosaic, and in it you can see the sun and 6 planets: Venus, Earth, Jupiter, Saturn, Uranus, and Neptune.
As we were studying the images, we noticed along one of these sunbeams, there was the Earth, that pale blue dot, which contains every single person. We realized just how tiny our planet is and how very special.
It's one of the most amazing and beautiful things I've ever seen.
February 1990. The cameras power down for the last time. But this mission isn't over. The Voyager probes are about to reach the edge of the solar system, a region no spacecraft has been to before. Far from the sun, at the very edge of the solar system, lies a vast expanse where no human-made object has ever entered. Until the Voyagers.
This is like early explorers leaving sight of land. They are just surrounded by a vast ocean of night, and they are all alone.
It's sort of like the boat going from the bay out into the open ocean. It's a whole different environment.
The Voyager probes are about to leave the calm of the solar system and enter the stormy waters of the galaxy. They start to exit the heliosphere, a protective bubble around the whole solar system, and cross into a combat zone that hosts a cosmic battle between the sun and interstellar space. Inside the heliosphere, waves of particles from the sun, called the solar wind, push outward. Outside, an ocean of gas and particles pushes back.
As the solar wind is expanding away from the sun, it's pushing against this thin stuff between the stars, the interstellar medium.
That's the last influence that the sun has in the bubble surrounding it. Once you cross that, you are in interstellar space.
The heliosphere's front line protects us from one of the galaxy's deadliest weapons, high-energy particles called cosmic rays.
Cosmic rays are like tiny bullets, and they travel at close to the speed of light.
December 2004. Voyager 1 detects a sudden drop in the solar wind, evidence that the space probe is nearing the heart of the battlefield, a region known as the termination shock.
The termination shock is the region where the solar wind starts to meet resistance, starts to run into something, and that causes it to slow down.
Voyager 1 picks up surges from both opposing forces, blasts of cosmic rays followed by waves of the solar wind.
The instruments on board Voyager didn't just suddenly change from sun space to galaxy space. It actually kind of went back and forth several times as it was measuring the energies of the particles at that region.
This suggests that the edge of the heliosphere is not a single battlefront, but rather a complex region of skirmishes, a sea of gigantic magnetic bubbles created by the sun's magnetic field.
The sun's magnetic field rotates with the sun physically, but this far out, billions of miles from the sun, those magnetic field lines get dragged by particles, and there's a lot of different effects on them, and they can get tangled up and loose. This creates bubbles, and some of these bubbles are 100 million miles across.
The magnetic bubble boundary is not watertight. Some cosmic rays blast through.
This heliosphere is much more foamy than we had thought. There are gaps in our defenses where deadly cosmic rays can find their way through into the inner solar system.
The foamy, defensive line blocks 90% of cosmic rays, but allows 10% through. As Voyager 1 passes through the battlefield, it detects fewer and fewer solar particles. Eventually, there are only cosmic rays and interstellar space. In 2012, the probe becomes humankind's first object to leave the solar system, followed in 2018 by Voyager 2.
It's been 50 years since the first satellites poked their way out of the Earth's atmosphere. And now both Voyager spacecraft have poked their heads out of the sun's atmosphere, are outside the solar system and exploring the galaxy.
The Voyagers cross the final frontier and sail the ocean between the stars. They don't see their first discovery, they hear it.
In space, no one can hear you scream. There's no actual sound waves moving around, but there are waves of plasma, of electrons.
So as Voyager passes through this, we can translate these changes in the plasma density to sound waves.
This is the sound of interstellar space.
Poetically, I kind of like to think of it as the song the galaxy is singing, welcoming Voyager to interstellar space.
Some of these sounds may even come from distant supernovas. Think about that, a star dying tens of thousands of light years away, and here's an echo of it here.
The sounds of deep space tell us more about our part of the galaxy.
As Voyager travels through the interstellar medium, we can use these sounds to map out its local environment. And since 2017, we've been mapping how these sounds get higher and lower and higher, louder and softer. And it's telling us that the interstellar medium is not uniform at all.
Built to last 5 years, Voyager 1 and 2 are now more than 40 years old. Only one final mission remains, perhaps the most important mission, to let the rest of the galaxy know we're here. The Voyager spacecraft are now outside the solar system. Our sun is just the brightest star among many. How much longer can the probes keep going?
The limiting factor on the mission has turned out to be power. And every year there are 4 watts less power to run each of the Voyager spacecraft.
There are no service stations out there. There's no way to, repair things that go wrong. And it's really remarkable, the fact that they're still out there in a cryogenic cold, operating. They're still working. They're still alive.
In just 5 years, there may be too little power to transmit signals to Earth. After a final message home, the Voyagers will fall silent forever.
This part of the Voyager mission, flying in interstellar space, is the long goodbye.
They're going to become our messages in a bottle. A little bit of humanity, representing us when we're long gone.
The 2 probes could survive for billions of years. And perhaps witness the biggest event of our galaxy.
5 billion years is the big date, because that's when our galaxy will collide with the Andromeda galaxy.
The galaxies themselves are going to be flying around the spacecraft. It's really remarkable when you think about it from that perspective.
It's unlikely the Voyagers will be hit by anything during the cosmic collision, but they may be flung out of the new galaxy.
During that process, stars get ejected into intergalactic space. It's possible that, flinging along with them may be one of the Voyager spacecraft. They could be not only, interstellar Voyagers, they could turn into intergalactic Voyagers ultimately.
Maybe the Voyagers won't just drift forever. Maybe they'll be found.
There was kind of a wonderful little jaunt of imagination that maybe if some alien civilization with incredibly powerful telescopes might notice that there's a little artificial object flying through space and be curious about it.
Strapped to each Voyager is an aluminum case. On the outer side is a map of how to find Earth with directions from different pulsars.
So why use pulsars to direct aliens to our location? These are the dead cores of stars after a supernova explosion. Well, amazingly, pulsars all spin at slightly different rates. So if you can actually triangulate your location based on the rates of different pulsars in the sky, you can actually have sort of a galactic GPS system. You can show the aliens where we are with incredible accuracy.
Inside each case, a gold-plated copper disc.
Looking back on it, it's really kind of this wonderful part of humanity. We sent aliens out there, unimaginably technologically advanced aliens. We sent them basically a vinyl record.
Yeah, the golden discs are literally discs. They actually are records with grooves. You can play them, you can jam out to them. It's got a soundtrack of our species.
The records have tracks by Beethoven, Blind Willie Nelson, and Chuck Berry. The sound of surf, of thunder, of birdsong, and a human heartbeat. So, will aliens ever find the records and give them a spin?
The golden record is a lovely idea, especially to energize and excite the public about this. Will it ever be found? There's a reason we call it space.
A tiny, cold spacecraft is a difficult target to find. Any species capable of detecting them would have a better chance of spotting our planet. But the Voyagers will long outlive Earth.
It's possible that they will find it millions or even billions of years in the future, long after we're gone, where there really aren't humans anymore. Or is there even a possibility that when we start traveling to the stars in the far future, we'll find them?
Awaiting discovery, or doomed to drift alone, the Voyager probes have already inspired one civilization, ours.
Calling these Voyager, it's perfect because that's what they are doing. They are voyaging out to the outer solar system and beyond and showing that there is no end to our desire to explore.
They've shown us countless wonders of the solar system and a glimpse of what lies beyond.
We, as a species, can build ships that not only sail the oceans of our Earth, but that can sail outwards to the other planets in our system and reveal new worlds.
They are the greatest space mission ever.
The legacy of Voyager is our remnant. It is our memory. It is a sampling of humanity that is out there now among the stars.
And if they last until the death of the universe, as the final stars fade and everything goes dark, they will be humanity's final statement. We were here.